Mobility Forum. This is session 160. We'll talk about the Tier 1 innovations in ADAS and autonomous vehicle. I'm Professor Jinhua Zhao, the professor of system transportation at MIT. When we talk about car industry, most public will know the car makers, the OEMs, right? The people don't really know much or care about the Tier 1 suppliers like Magna, Valeo, Bosch, Denso, OPO Mobility, etc. In fact, though, most of the automobile innovation actually come from Tier 1 suppliers. They are the key contributor that drive the automobile technology innovation there. While the landscape today is changing, right? The industry is shifting towards this advanced driver system, ADAS, and autonomous driving. And cars are more and more software-defined, connected, and computational. And the relationship between OEM and Tier 1 relationship, I would say, has been rather stable over the years, but no longer. Right? The Tier 1 is getting pressures from both ends. From the top, the OEMs try to develop and own their own softwares. And from the bottom, the high-tech companies, the chip makers like Nvidia, Qualcomm, Mobileye are moving up the stack to offer full platform solutions. Right? So one side, the Tier 1s must defend the high-volume L2 ADAS market to generate revenue today. At the same time, we had to fund this high-risk, high-cost R&D for this moonshot project for L2 autonomy. So we are really excited today to have three leaders in the industry. Paul Schmidt from Torc is a subsidiary of Daimler, Harold from Valeo, and David from Magna, to share with us the progress and contribution made by Tier 1s in ADAS and AD hardware software development, and their latest strategy and future product line and the general vision forward. Right. Without further ado, let me pass the forum to Bhuvan, who designed and will moderate the session today. Bhuvan, please.
Thank you, Jinhua, and good afternoon, good morning, good evening, everyone. We have quite an interesting panel for you today. In the past, at the Mobility Forum, we have discussed research on silicon photonics systems, solid-state LiDAR, but have not really covered what is currently in use in vehicle fleets across ADAS, advanced driver assistance systems, and AD and autonomous driving systems. So just to set some context, I'm just going to share the 5 levels of driving automation. This is an SAE chart from 2021. And typically the initial levels of 1 and 2 are what one calls as ADAS. These can include lane centering, adaptive cruise control, or lane centering, adaptive cruise control at the same time, automated emergency braking and other warning systems. And level 3 onwards is where the car is actually driving for you, and it then constitutes an autonomous driving system. So just setting some context here before we move on to our presentations. So yeah, a quick question, and you can put this your answers in the chat. If your car is equipped with an ADAS system and you do use it, which feature or features do you use the most? Like lane keep assist, lane keep warning, adaptive cruise control, dynamic cruise control, these sorts of things. So maybe you can just put it in the chat for our audiences to quickly have an idea of what ADAS features do you all use. Yeah, and I mean, no car. That's good. Okay, so I see some folks have all of them turned off. Some have lane keep assist, warnings, highway assist. Some have all of them turned on. In stop and go traffic, adaptive cruise control. GM's Blue Cruise is impressive, yes. Low speed ADAS features. Okay, so you can keep that going while so yes, so as Jinhua mentioned, a lot of the innovation in the automotive space, Tier 1 suppliers have been quietly working in the background as the backbone of automotive innovation. And this is not to belittle or trivialize the role of the large automotive manufacturers in integrating and actually manufacturing a car, but just to highlight how critical Tier 1 suppliers have always been. But as the industry is shifting to more software stacks, these hardware sensors, a lot of silicon, the innovation landscape is beginning to look a little different. And a lot of the media narrative is driven by what Waymo is doing, what Zoox is doing, the big tech guys, and chip companies such as Nvidia, Qualcomm, Mobileye. They are driving a lot of the public narrative. So this panel brings together experts from a global OEM, a Daimler subsidiary Torc, and 2 global Tier 1 suppliers, Valeo and Magna, to explore, what's happening within their companies and how they are contributing, what challenges and opportunities are they seeing in this ecosystem. So we'll start off with 3 quick presentations from each of our panelists, and then jump into some discussion, and in the last 10 minutes, audience Q&A. So in no particular order, let's start with David. So David, if you can get your screen share on, I'll quickly introduce you. David holds a PhD in electrical engineering from Rensselaer Polytechnic Institute, RPI. His research was focused on LiDAR data analysis, including object detection, segmentation, and 3D hole filling. After spending time in defense research labs, he spent many years at Here Technologies, building and leading teams to develop, implement, and produce algorithms for the high-definition maps. More recently, David has joined Magna as Director of Engineering and drives many initiatives from next-generation ADAS to state-of-the-art sensors and vehicle architectures. David, the floor is yours.
Great. Thanks, Pavan. This is a great forum. I appreciate the invite today. I'm going to really lean into your point about most people don't know even what is a tier 1 or anything about them. So, we've only got 8 minutes, so, hope to squeeze in as much as we can there. When I joined Magna almost 4 years ago now, I had also no idea. And when I learned some of these numbers, it's really shocking how little idea people really do have, right? So when you talk about autonomous driving, a lot of the companies say, we just did this big new round of funding. We've got 400 people now, right? Magna has 164,000 people. So, I mean, the scale is, many orders of magnitude from some of the other efforts that we're all familiar with. You see we do almost $40 billion in sales. We've got 337 facilities around the world, and that's what leads to us being the #1 supplier in North America and #3 in the global market. So it's really a big place. You can see the breakdown here. We don't need to dwell on it, but across 4 continents, doing literally every part of the car. What's interesting is that every part of the car really leads to a lot of efficiencies and really understanding of the vehicle system that you can't get when you're only focused on part of the car. So these are essentially our major subsidiaries. We do everything from seating, mirrors, full-on stamping for chassis, all the way around to where I live, which is in electronics, where the software and the DCUs and these kinds of things are hosted. I was at a conference one time, internal with some guys, and somebody was from seating, and I was kind of joking with them that, hey, I'm working on all this advanced ADAS stuff, you're building chairs. That doesn't sound very fun. And they said, no, let me explain. Even with the seats these days in the cars, there's many hundreds of microchips, because you've got air conditioning, heating, the seats that move with you dynamically to support your body, the airbags, the seatbelt warnings. I mean, all these things, when you really add that up, every part of the vehicle these days is very complicated and very sophisticated, and it takes a lot to put all that together. So it's kind of cool to be part of that big ecosystem. So when we focus on Magna Electronics, we more or less do 3 things. We make sensors, we make compute units, and then we build systems out of those things. You can see here, we basically cover every type of sensor that you're used to seeing. So we make a lot of radars, we make a lot of cameras, both interior and exterior. We make some kind of what we call next generation sensors with thermal cameras and imaging radars. Of course, the ultrasonics for some of the low speed stuff. We don't necessarily build LiDARs, but we do integration of LiDARs and full systems. So you can see we basically have the electronics components that you would imagine covered here. When you look inside the car, it becomes a little bit more about form factor. So you can see here we have a lot of products, but they're cameras in pillar 1, camera in pillar 2, camera in the mirror, camera in the center. So the customers don't want a big protrusive thing sticking out of their car, so you have to find ways to hide these. Again, it turns out the power of the systems thinking is we have a mirrors division. So when we want to make a mirror with a new camera in it, for driver monitoring or occupant monitoring, whatever the case may be, we can work together with the experts already who design mirrors, and we can kind of co-design products. And we have a lot of very large commercial wins exactly because of those kind of things. We talk about in the industry, a 2-box solution versus a 1-box solution, where if you have thing 1 and separately thing 2, you have costs associated with sealing and heat dissipation and blah, 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 that if you combine them into 1 box, you actually get a tremendous amount of savings. And when we're talking here about, objects that cost $40, if you save a couple of bucks, that can be many percent. So kind of working together between the electronics specialization with the other parts of the car lead to a lot of efficiencies. If we focus on the software for a minute, and that's kind of my background, we talked about I'm kind of a LiDAR guy by academic training, and then spent a lot of time with HD maps and doing some of these ADAS features. That is a lot of what the customer sees, right? So all these sensors are kind of behind the scenes. The features are the things that you get a button and you get an indicator and you get flashing on the screen. This is kind of the portal into all of the rest of the stuff that I just talked about. The customer doesn't see the DCU and all of the compute platforms, but they see the result of those things working together with the sensor systems. So, I saw a lot of these words flashing up on the screen when the people in the chat were posting what are their favorite ADAS features. And, these are starting to be almost commoditized in a way, right? I mean, even you go to an airport and you get the cheapest rental car you have, you're just going to a meeting half an hour away, you'll find a lot of these starting to be present in the cars. Especially the adaptive cruise control, the lane centering. I mean, these are starting to be terms that the general public knows well. We kind of break them down in ADAS a little bit differently. I'll call it like a laundry list of features versus if you look at an autonomous driving system, they typically consider it more of the driver. So they have, for example, the Waymo driver, and it does all the things. Here, we don't necessarily sell them individually, but we think about them quite individually, and we kind of package them up for customers in different sets. Generally related to what we call the trim levels, right? So low trim, you may only have a couple of sensors, you can only support some subset of the features. Then you go all the way to high trim when you've got whole bunches of radars and cameras, now you can kind of support the full feature set. And that comes also along with the amount of compute that you have available. If you have some very small TI TDA4 type of chip, you can only do something. And then if you have a big, you saw probably a commercial announcement, Magna working with Nvidia and a new next generation Thor platform. We can all of a sudden do a tremendous amount of compute, which opens the doors to a lot of these sophisticated new features. This is, we talked, there was kind of a bullet to request talking about the scale, right? So you can see, hey, we make cameras is a little bit different statement than we've made almost 200 million cameras, right? So I mean, that shows not only expertise in kind of design of the sensors, but also production expertise, and that's where when we kind of joke in automotive, is a lot of these sayings like something's on your radar or rubber hits the road. That's where really the rubber hits the road, right? You can have an engineering lab design the coolest new tech in radar, and then if you don't know how to manufacture it, what's the point? Or there's a tremendous amount of years between that and the manufacturing and the eventual sale to OEMs, unless you can kind of consider that full pipeline right from the beginning. And some of these statistics, I think, speak for themselves. I mentioned we kind of have multiple roles in the automotive landscape. So, number one, we do manufacture components. We like to not think of ourselves as simply a component manufacturer. And in fact, a lot of the OEMs are starting to prefer not dealing with simply component manufacturers. They want us to provide, fully functioning subsystems, in some cases, full systems. Not just, okay, here's your CCD that's been packaged in a little plastic housing, although that's also hard, I've learned recently, taking that, then connecting it through the vehicle architecture to whatever the computer is, and providing the ADAS stack, and providing the HMI. So I mean, this full suite of things where the OEM can kind of pick and choose what they want to focus on, and we do the rest, versus coming to us and, hey, can we buy a camera, and going somewhere else, hey, can we buy a radar? So that integrator capacity really is a tremendous value add recently in the way that OEMs are thinking about their products. I mentioned before, I just kind of wanted to differentiate a little bit the way we think about these SAE autonomous driving levels. In fact, I gave a talk recently at a conference. We called it scope creep in L2, right? So if you look at that list that was flashed on the screen a minute ago, we've got L1, L2, and then everybody says, but then the cool stuff starts after that, right? L3 is now driving for you in limited cases, L4 maybe moving into urban. Well, that's more or less a fair distinction. L2 is starting to be something that, you know, Magna has a public position that we are playing in the L2 space right now, of course, watching the higher level spaces, but L2 is where, you know, this large majority of our products and future products even are focused. When you read that SAE description, it says, you know, 2 or more features, you know, lateral and longitudinal control at the same time. Like, you know, that sounds a little bit minimal, but think about what that really means. I mean, you can get all the way into the latest, greatest features we call urban navigate on autopilot. And what that means is L4 where the driver is still responsible, more or less. So, you know, the takeover rates and these things, of course, are critical, and, you know, driving those to zero is extremely hard. And that's you know, maybe why the OEMs haven't switched to L4 yet. But what do we actually need to do within L2 is essentially everything. We have full perception stacks, both at high speed, long range, and complex urban conditions. We have drive policy that ranges from, you know, on and off ramps to now urban intersection navigation and these things. So I mean, it's really a different approach to the same problem with kind of this lining of legal responsibility difference. So scope creep in L2, I think, is a really good way to summarize at least Magna's position on the industry at the moment. We won't dwell here. You know, also what we have is the constraint of cost, right? So if you know, pick on Waymo only because, you know, they're awesome, but if you look at the sensor suites and the compute suites, I mean, these things cost tremendously more than we have budget for when we talk about a production OEM car. You know, we talk about the trunk full of compute and these types of things. You know, we're getting more and more compute. In fact, the curves are kind of crazy. It's almost exponential how much more compute we can assume every couple of years. But that's still, you know, far behind what we get in an L4, a typical L4 system. Let's see. So as we look into kind of next generation, sorry, this is a little bit rushed, but just trying to squeeze in what we can. You know, it's continuing to look at safety, comfort, and then parking. Parking is one place where there's a lot of room for improvement. I mean, there's a very visible difference between, hey, you're driving around, identifying a parking spot, and then, you know, pushing park, and the automated parking takes over, versus kind of the holy grail here is what we call valet parking, where you drive up to the restaurant door, you get out, and then the car goes and finds its own spot and parks. You know, these are, you see in the Tesla type systems, things like this starting to become possible. So I mean, these are things that people are actually actively working on, including Magna. When it comes to comfort, this is what I mean by like the navigate on autopilot features. So we're near production with the highway navigate on autopilot, and then we're moving towards the urban in the near future. And then safety is just more and more cases that get covered with different types of cross traffic, different speeds. You know, now getting 360 alerts versus just, you know, forward and rear alerts. And one that's actually very interesting, we call V2X, or connected ADAS. When you don't have line of sight with something, which is actually in urban conditions quite a bit of the time, you know, if someone flies through an intersection and you couldn't see them because there was an occluding truck or building, starting to think about ways that we can transmit information about the environment even when there's not the line of sight for traditional perception systems. So, you know, huge amount of work still to do here, and we're kind of exploring across these all these different avenues. One that I'm kind of particularly interested in, my group spends a lot of time focused on, is sensor fusion. And so this is when I said we're moving kind of from forward looking to 360 looking, that's one of the major things that enables some of these new highway features, where you need to have context, not only the traditional, you could describe some of the early L2 features as stay in your lane and don't crash into the thing in front of you, right? This sounds like a simple problem. But what we need to do now is change lanes, you know, change back on and off ramps. You need a much better 360 awareness. So not only do you need more sensors around the car, but now you need to be able to hand off detections, you know, as you move between sensor field of view, and you need to have, you know, the full environment picture at the same time in order to make you know, route plans and trajectory plans through these, you know, more complex environments. So, you know, traditionally in ADAS, we do what's called late fusion, and some of that is due to essentially the vehicle architecture. They've had compute in the sensors, what they call smart sensors, for a long time. That's been the preference for the OEMs. So we have, here's a camera. It's not just giving you streams of pixels, it's actually giving you objects. So it's doing object detection, reporting in a very lightweight way across the vehicle network. Here are the objects, and then it's up to the central compute to kind of then make the plan and execute the plan. What we're seeing the desire for more and more advantages of, especially as you get into some of these more heavier ML approaches, is let's actually get the raw data to the central compute, which requires two things: higher bandwidth network and more compute power. But once we get all that raw data in the same place at the same time, we can kind of defer the logic to the neural networks, and we can make really great pictures of the environment, all in one shot. So moving from perception in a distributed way to perception in a central way is one thing, and then moving the drive policy from kind of a heuristic approach to also a machine learning approach. That's kind of the other big thing that we're looking at in the future.
David, I think I'll have to cut you off because
I think I made it.
Okay, perfect. Thanks for that. We'll come back to it in the discussion session. Paul, I'm going to turn to you next, sandwich you between the two tier ones. So as you get your screen, I'll quickly introduce you. Paul Schmidt is Senior Software Manager for Autonomy Applications at Torc Robotics, where he leads safety critical systems, engineering, and machine learning acceleration efforts for long-haul autonomous trucking. He serves on the boards of advisor for several robotic startups and is the founder of the Safe Machine Learning Collaborative. Previously, he's worked across Motional, iRobo, Volvo, and Ford. Paul, the stage is yours. You're on mute.
How's that sound?
Yep.
All right. Pleasure to be here. Thank you very much, Bhuvan, for inviting me. Really excited to be here and talk about, share some insights about our hardware and software platform from Torc, where we're driving the future of freight. For those of you that haven't heard much about Torc, just a little bit about who we are. We're focused on L4 autonomous long-haul autonomy. We were talking about the different SAE levels earlier. And our core product is the fully integrated software and hardware solution that we call the virtual driver. A bit about our history. Our history really goes back to the DARPA Urban Challenge back in 2005, 2006. This is a picture of the Virginia Tech entrant, the Victor Tango car, crossing the finish line. There weren't too many vehicles that actually crossed the finish line that day. And shortly after this day, Torc was founded. And so if you think about it, Torc is really a pioneer within the autonomous vehicle space. And for the last 6 years or so, we're proud to be a part of another pioneer, the Daimler Truck Corporation, which, as we know, is a leader in the truck industry. So Bhuvan, you talked about relationships with OEMs. We can get more into that later on if we want. A bit about our footprint. We're not as global as David in Magna. We're in one continent. Our headquarters is in Blacksburg. Our fleet operations is head Dallas Fort Worth area, and then we have engineering complexes in Ann Arbor and in Montreal. And a bit more about what we do. Again, I mentioned we're into L4 autonomous long-haul trucking, where we aim to be a leader in fleet logistics solutions. We want that to be a scalable and profitable reality. We're launching next year and then scaling shortly thereafter. And we're focusing on safety first in everything that we do, and reliability and operational efficiency. Okay, before I get into the hardware and software, I want to talk just get into the world of freight for those of us that aren't too familiar with it. I myself, I've got a commercial driver's license, so I'm somewhat familiar with this, and the punishing duty cycles. These trucks, they have long driving hours, back to back, day to day. The mileage the trucks are accumulate, and they're rated for mileage that's an order of magnitude greater than consumer grade cars and trucks, I'll say. And of course, at high speeds. And so this really pushes the boundaries of the design constraints for the compute, the power, and the thermal aspects. Also want to highlight the high gross vehicle weight requirements for these vehicles that go up to 80,000 pounds for Class 8 trucks, which drives typically longer stopping distances, which drives the need for longer range sensing down the highway corridor. Okay, so with that as a backdrop, let's get into the sensing and the general vehicle platform design. So proud to say here at Torc, our sensor suite is full multimodal. So we have cameras, LiDAR, long, short range, radar, long, short range, to really build that robust, high resolution model and understanding of the environment and surrounding actors. And going under the hood a little bit more, we'll talk about our actuation system. It's fully built. All the sensors and actuation, they're fully built into the vehicle by our OEM partner, Daimler Truck. So the Cascade truck comes with a control by wire, the steering by wire, braking by wire, throttle by wire systems. And they're fully redundant. So the by-wire systems have full backup, they fail operational, and then our sensor systems as well. If we have a sensor that goes down, we still have that robust view and understanding of the environment. All right, now I'm going to shift over to our compute platform. David, I think you said a trunk full of compute. Well, we've got a truck full of compute. How's that? Really happy
Mm-hmm.
earlier this year, we announced our partnership with Nvidia and Flex. And this was all about designing and delivering an automotive grade high performance compute platform. I think, David, you used the term production expertise. I think that's automotive grade. We're in the same space there. What do I mean by that? It's high quality, it's manufacturable, it's robust. It's robust across the full temperature range of automotive applications and the vibration, rigor that the systems go through. And it can scale. So it enables us to scale our solutions for our customers. All right, now switching from hardware over to software. Really happy. Earlier this year, we announced our AV, what we call 3.0 software blueprint. And there's three aspects of the AV 3.0. First, it's end-to-end reinforcement learning. We're really excited about this, that we feel that this will give us the high-performance AV driving our customers need and expect. But it also includes a monitor, a heuristic guardrails. This enables enforcement of the basic rules of the road, enables traceability and verifiability of those. And a key aspect, it's not just a full black box from photons into trajectory, it's modular. And that enables us to go under the hood. We can see the inputs and outputs. We can see where the system's performing well, where it's not performing so well. So it enables introspection at a very low level, which really facilitates debugging and validation. Okay, so I want to double click on I mentioned the heuristic guardrails for our full machine learning approach. I want to double click on that a little bit because at Torc we wanted to bring safety not just to the reinforcement learning pipeline, but also down to the development pipeline where we're developing the models, the machine learning pipeline. And so really proud to say earlier this year, we published a paper on what we called Introducing the Machine Learning Failure Modes and Effects Analysis, or the MLFMEA. We published this at the SAE World Congress. It was very well received. It's been well received by both two different communities. If you think about it, the machine learning community and the safety engineering community, which have different vocabularies, different cultures, shall we say. But this really gave them a common vocabulary, common roadmap, forced them to ask the right questions at the right time and focus on the key areas of risk. So it was very well received. We open sourced the method and the approach. And based upon the response, we formed a collaborative of companies that are each contributing, their lessons learned on the approach and helping to make it better. And perhaps, and we've got a few members on standards committees, so probably weave its way into a standard in the not too distant future, which we're really happy to say. If you want to learn more, talk more about that, happy if you want to learn more about the collaborative or even join, happy to talk about that. But let me just conclude, in terms of trends, what's next? On the software side, happy to talk more about end-to-end architectures. On the hardware side, we see the trend towards more integrated solutions, not too dissimilar from what David was just talking about. That's what our customers demand and expect to see. to lower their risk. But also I want to highlight an ecosystem trend. We're integrating our system not just within, our customers' logistics systems, but we're also integrating it into, the transportation network, into society. So I'm really proud at Torc that we work up front with policymakers, at the city, state, federal level, and even with first responder communities. We had a wonderful Texas road tour. We're introducing the technology and to that community. So with that, Bhuvan, I think I'll leave it at there. Really, thank you for the invitation and opportunity, and happy to talk more.
Yeah, thanks, Paul. We'll definitely dive into AV 3.0 on the paper and the questions and discussion. But meanwhile, let's move on to Harald. Harald, if you could get your screen up. So Harald Barth is responsible for product marketing and driving assistance at Valeo, focusing on global strategy and communications for ADAS and automated driving systems. His role includes supporting marketing intelligence and shaping solution approaches. Before this, he managed parking assistant projects within the company and has been with Valeo for, I think, over 27 years. He holds a master's degree in business and engineering from the University of Applied Sciences in Karlsruhe. Harald, the full floor is yours.
Thank you, Bhuvan. So it's all making mobility safe and more pleasant for everyone. And there is an emphasis on all of that, on the mobility, on the safety, of course, and the pleasantry, the enjoyability, and the part of for everyone. So just quickly on Valeo, we're also global automotive supplier, purely focused on automotive. We are split in three what we call divisions: power, light, and brain. Power is all about electrification and the powertrain. So both for a combustion engine, but more and more also for electric vehicles. Light is all about seeing and being seen. So it's not only lights outside, exterior lights, but also interior lighting, also wipers, which is also has to do a lot of with safety. And then last, brain, where I'm hosted, which is interior space, the interior cocoon, as well as the exterior sensors and perception and driving assistance and automated driving functionalities. And that's where we really furthermost focus on that safety aspect and making the travel enjoyable to everyone. From a global perspective, we're quite well balanced globally. We have more than 100,000 people. On our revenue, about $25 billion last year. Okay, we have a French heritage or European heritage, so about half, a little less than half of our revenue we are doing in Europe. 1/3 is in Asia, and about 20% we do in Americas. So that being said, let's say in driving assistance, our heritage, our foundation is in parking assistance. That where we have more than 30 years of experience on camera systems and predominantly also ultrasonic systems, which made us, and we're still a leader in that area for parking and surround view. Since 20 years, we also helped keep people and motorists safe at all speeds. So that's active safety systems like emergency braking or lane keeping, lane centering, ACC, and that's today, it has been mentioned by David before, with this level 2 or plus and navigate on autopilot systems that gain, let's say, a lot of market share. I think one of the guys in the comment mentioned for Blue Cruise, GM Super Cruise, great systems. And then also we're working in automated driving. We started the LiDAR development to pick that out about 15 years ago. We were very early in that in the automotive field, and our LiDAR perception systems are powering the first level 3, the first approved level 3 vehicles on the road, both in Europe and in the United States. And we have validated these kind of systems even further also in Asian markets and other European countries. So to name an order of magnitude, maybe, we deliver about 30 million driving assistance, parking assistance systems every year. Or to put it the other way around, 1 out of 3 new cars globally comes with some ADAS technology from Valeo. When we look at the market, taking a very black and white simplistic view, we see 2 main approaches there towards the ultimate goal of achieving automated driving everywhere and at any time. So we have this approach A, which is shooting to achieve trustworthiness first, and then after that expanding availability. So that's the level 3 systems in the market. That's the robotaxis. Waymo has been mentioned before. There are other players in the area. And this approach A is going to face a challenge in the downscaling. It has been mentioned, a Waymo robotaxi. It's quite expensive. I mean, it's come a long way, but it's still quite a lot of engineering in that car. So scaling it down for a mass market will be a challenge, or is a challenge. While the other approach, the approach B, which is first trying to make it available as much as possible and then working on the trustworthiness, is what we see this, it's on the slide, level 2++, navigate on autopilot, the NOA, and then afterwards work on that. And is facing another challenge, as making the step from a supervised or level 2 system to an unsupervised or level 3, level 4 system is not just an iteration. While you, of course, can reuse a lot of blocks or building blocks, sensors and software parts, it's a quite different architecture where you have a main and a fallback path starting from the sensor all the way through the system to the actuators. I think, Paul, you have mentioned it with your truck architecture. Thanks for that. So from a perception view, sensing view, I think we're quite clear there that for safe automation, we need a multimodal approach. So talking about the sensors, different modalities. You see ultrasonic, that's sound. You see LiDAR, camera, radar, even acoustics with a microphone, or thermal with far infrared. Each of those modalities, they can supplement each other and also create a redundancy among each other for robust and reliable perception. We at Valeo, we are proud to have the broadest portfolio of these kind of technologies in the industry, and which is what is not on the slide. We also cover connectivity and telematics, so to keep the car connected for your pleasure, but also for safety and to exchange real-time information about environment and traffic. So we cover both entry variants and also high-end variants, with the main differentiating factors would be detection range, the field of view, or the resolution of the sensor. And prices can range from just a few dollars per sensor up to a couple of hundreds of dollars on the more expensive side. But we've come a long way. For radar initially were quite expensive, and LiDAR at the beginning we spoke about a couple thousands of dollars per sensor, and we brought it down significantly into the 3-digit area. So it has been mentioned also before that it's not just bringing this data together, but we also have to manufacture these sensors. And that's far from trivial. In many cases, we are talking about micrometer precision and tolerances that needs to be kept over producing millions of them per year in multiple facilities all around the world at a constant quality. We have to reliably work to spec over a large temperature range and often violent vibration, specifically, Paul, in the trucking business, that's quite a thing. So those sensors have to work over lifetime. And then it has been mentioned before by David, I think there is a quite brutal, call it Darwinian cost pressure in automotive industry. So while those sensors needs to be super quality, super robust, and really good to spec, but they have to really be super cost efficient. So far, talking about Valeo, we have shipped well over 2 billion of these kind of sensors to date. So we do have accumulated some expertise in that area. So talking about the total market, at Valeo, we have quite a pragmatic market approach. So sometimes we're selling individual components. Sometimes we're selling complete turnkey systems. That really depends to the OEM. Someone's the first, someone's the latter, someone are picking in between. That's quite pragmatic. Where we can do good business, we go for it. Obviously, I cannot talk too much about concrete project, but I can name a few close collaborations we have, like with BMW or for Renault or Volkswagen. And we also supply complete ADAS systems to Geely and other brands in China and elsewhere in Asia. Another aspect, talking about partnership, is that we also partner on the tech side, on the supplier side. So we are successfully collaborating with Mobileye, which is a subsidiary of Intel. We partner with Qualcomm, and we recently announced a new strategic partnership with software company Momenta in China. What's interesting here to mention maybe is that talking about these partnerships on the OEM side and on the tech and supplier side, while we are collaborating with these partners on the one side, quite often we're actually also competing in the same area with them at the same time in other cases. So a couple of years back, I heard someone mention the word frenemy. So it's friends and enemies at the same time. And that's actually far from easy. We have to be open and transparent, and we have to trust each other on the one side, while we have to protect our intellectual property and our competitive edge on the other side. So that's a real management challenge that does not get enough, let's say, attention quite often. So I have discussed the sensors and the importance of the multimodal approach. And yes, perception is hard. Telling the signal from the noise is really not easy. And also the sensor fusion is hard as well. I think, David, you mentioned one of the aspects there, or one of the approaches there. But when done well, the sensor fusion, it provides the reliability and robustness that we really need to achieve a safe automated driving. So talking about the sensor in general, there's been a lot of advancement in recent years, with AI obviously taking the center stage. I'm certain that a pure end-to-end approach isn't a silver bullet, as we also need the behavior of the system overall to be explainable and predictable. Paul, I think you have mentioned there this hybrid approach. I really think you have pointed it well out there. And I'm also quite sure that we haven't seen the last in software and specifically in AI innovations. So there is going to happen a lot of innovation and progress in the coming years. So last, let's talk about quickly the hardware. One is also a leader in compute hardware. So we need these high-performance computers that you have seen a picture before as well in the back of the Torc truck. And we start our portfolio with a highly affordable solution. You see a camera, a smart camera here in the graph, where we are using a smartphone camera actually as a host computer, hosting all the parking, active safety, and driving assistance feature in a vehicle, where we connect radars, ultrasonics, and further cameras to that host computer, super compact, super cost efficient. On the other side, we also provide central ADAS computers to the BMW Neue Klasse, if you have heard of that. And we're also powering new generation of ADAS in Renault and Volkswagen. And also we have won several businesses for that in China. And then finally, talking about software-defined vehicle and a real central computer in the vehicle, our first multi-domain modular central computer is going to launch in 2028. And that's a very exciting project we're working on, and that's really the future.
Harald, I think we'll have to get into some questions now. So
yeah, I think that's fine. Just last one, really, it's about safety and making travel more enjoyable. And as we are talking a lot to students here, talking all about the technology, it's really the people that make the difference. So what we really need is the right people with the right education and the right, let's say, emotional and motivation behind. Thank you.
Thank you. I think you addressed some of the questions that we were going to ask on, do you compete or collaborate with, the new players such as Qualcomm and Mobileye? And you mentioned the whole frenemies thing, which is very tricky. So, I mean, and a question to you, David and Harald, both of you, is like, how do you create a moat in this, a competitive moat? And maybe Paul, one question to you. I think I can on maybe to all of y'all. David mentioned from moving from the sensor level to sensor sending the data to the chip, and they're integrating different types of sensor data to achieve this fusion. A lot of comments in the chat about Tesla famously using only cameras, as other sensors can introduce noise. So maybe Paul, you could comment on the sensor fusion bit a bit, and then David and Harald a bit on the how do you create a moat with these new players.
David, if you want, let's go first. I've been talking about a lot now.
Yeah, sure. So, I mean, it really takes the whole supply chain. I mean, it becomes an ecosystem, not just a product, right? I mean, it doesn't make sense to think about any of this in isolation anymore. I mean, I guess back in the day, maybe a little bit before my time in automotive, you could source the sensors almost separately from sourcing the compute, almost separately from sourcing and designing the vehicle architecture. Right now, it really, you have to make a lot of code decisions about the approach you're going to take and the devices you're going to use and the software you're going to need to implement there. So
does that mean you have to work more closely with the OEM, and the OEM can't just pick and choose, hey, I want this part from you, that part from the other guy, but it has to be a coordinated system, all the sensors.
I kind of mentioned the move away from OEMs wanting to source devices and more wanting to source subsystems, right? So that seems to be a common trend. What they wanted. There was one question in the chat I just tried to answer. Somebody said I didn't hear anything about the UI. I said, that's a part where the OEMs seem to fairly unanimously want to own that. So they don't want their car to look and feel just like the next car, and that's what happens if the Tier 1 does it, right? So the OEMs really are different in their approaches on different things. So as a Tier 1, we have to support all of those. We get a lot of kind of information efficiency by being able to talk to a lot of the different OEMs and find out what really are the common parts, so we can invest our development effort in something that we can sell over and over, instead of just doing one big project for one OEM and then throwing it away. So I mean, there's a lot of aspects here. I don't know if that helps answer the question, but it's not really about competing as much as like collaborating makes you more successful here, I think.
Harald, anything to add, or I can move on to the sensor fusion with Paul? Yeah.
Maybe just two aspects there. I think, again, I'm coming back to people. When we work together, we really need to have the right people trusting each other. So it starts from the top, but also on a working level. We have to work to have a real, let's say, relationship and a trust, if the partnership, if the collaboration is aiming to be sustainable and a long term. And then we clearly have to define the roles and the responsibilities. Really, we have to be clear who's responsible for what in the system, specifically when we're talking about, is it a component, a system, a subsystem? And we have to ensure that both sides take a benefit in the collaboration. If it's off, it's not going to sustain.
Yeah. Paul, given your expertise in this space, I'm turning to you for the question on, the sensor fusion, and a lot of questions in the chat on that. Yeah. Comments as well.
Yeah, again, like I mentioned, we're a believer in the multimodal sensor architecture. Like I mentioned, it brings weather robustness is key for us. With that, we'll have the the radar that can see through, a rain. We've got the LiDAR that can, help see through fog. Dust storms is an issue, for our routes in Texas. So we're a full believer in that. Maybe also, Bhuvan, I think maybe to address the question about, level of data that's transmitted from the sensors to the compute. Yeah, we're, without getting into too many details, we're a believer in the raw data from the sensors. We think that's the right mix for the piece price for the sensors, but also allows us, to enable and leverage our high performance compute that I mentioned to really suss out the interesting bits of information from the sensors to build that, really robust understanding, that high resolution model of the environment so it can make smart decisions. Hope that helps.
I want to give time, for the audience questions. So, Jinwa, do you have any comments or questions before we turn it over to John?
Sure. I think given the time, let's give it to John directly. And I may add some remarks, but John, yeah, please.
Okay.
Okay, super. Well, lots and lots of questions and comments in the chat, as always. I'm going to try to put these into some buckets. So the first bucket was really around sort of consumer-facing cost and affordability for customers around ADAS equipment. The second bucket was on the reverse side of that, and it was about the business model and the industry structure. Questions about ADAS as a service, and what are the sort of, how are you guys thinking about delivering these enhanced safety features on a subscription model? The third bucket was around infrastructure, some questions around policy. There was a question about, do we have to change the road network and the signs? There's a question from Ellen Partridge about, what are the enabling policies required? So there was that bucket. And then finally, lots of questions around the technology. So why don't we just touch on that first bucket, which is the cost and affordability issue. I mean, we're living in a world, certainly here in the US market, where the average new car price, according to Kelley Blue Book, recently surpassed $50,000 for the average new car price. Similar trends in Europe. You guys are putting this great equipment and functionality into vehicles. Just give us a little bit of what's the other side of the conversation. How are people thinking about this sort of challenge of affordability in the automotive markets?
I mean, to my knowledge, Magna doesn't get into the subscription stuff. That would be fully an OEM decision. So it's not something that these subscriptions are not really doing anything cloud-based where you actually have to serve the product. It's more about just how you're generating revenue from that, right? So we provide the OEM the software, and then if they want to license it versus sell it, that's kind of their prerogative. So we kind of disassociate from that problem very intentionally.
Can you give us some insight in how OEMs are thinking about that challenge?
I don't work on that side of things very much. I mean, it's really like a business concept more than a technology concept. Personally, I talk to a lot of consumers about this kind of stuff, just kind of casually. I haven't heard one of them that likes the subscription model. So I mean, it's going to definitely be an uphill battle if they find that that's the direction that the OEMs want to go. But some are definitely going that way.
Okay. Maybe if I can add two things on the cost side, I think that you put it spot on. Cars have become quite expensive, not only in the US, also on a global scale. I mean, also the cars today, if you compare them to cars 20 years ago, they are quite different animals from various aspects, not the least safety and comfort. But we also have seen in recent years, I'd say, a few startups arising that try to put a more frugal approach in the market, and will definitely have a look how they make a living and what's the progress there. On the business model, I'd say with the software-defined vehicle architecture, I mean, on the one side, it doesn't really help the cost issue, because with a software-defined vehicle, you're basically putting a lot of hardware in the vehicle as a standard. Whether you pick the option or not, whether you pick the package or not, it's just there, all the sensors and all the compute. But once it's there, then it's the OEM has really the liberty to use different channels to market a technology. You can either buy it in a one-off, or you can buy it in a subscription or in any other model, or a pay-per-use or whatever. And some OEMs have started to try out stuff in recent time, and I'm pretty sure we will see more trials there, testing the water of the market. And then it's the other way around as well. The market is going to react, and the OEMs will see what sells and what does not sell. And in a few years, we will see a consolidation there.
Paul, any reactions from your side on any of the questions? We really got a lot of different varied reactions on the chat.
Yeah, sure. For the next hour and a half, sit tight. Be happy to give an answer. No, I'll just, for the sake of time, I just stay on the cost. So obviously our model is very different, and I'm a technology guy, so don't trust anything I say about the pricing model. But I think it's fair to say that we're looking at a range of spectrum of services, depending upon how deep the technologies is incorporated into our customers' logistics systems. So, if we have a larger ownership of the logistics, there would be a different price than, say, if it was, more seamless for our customers. So I'll leave it at that for the sake of time. Thanks.
Paul, there was a specific question about the trucks. Are they electric?
Yeah, the Cascadia trucks that we're working with are fully diesel. And I think that also enables us to power the high performance compute as well.
Yeah, exactly. Just any thoughts from anyone about the compute power for as we move from L2 more toward L4?
We have seen a clear trend in compute power in vehicles. We have come from, let's say, 1 to 10 to 20 trillion operation per second to take just that KPI. And we have arrived at several hundreds, in some cases, even thousands of TOPS. So while on the one side, we clearly also have to work on the software efficiency, with the innovation going on, and we see that clearly in the market. The next generation of vehicle, we are really talking about a lot of compute we are putting in the edge in the vehicle, in addition to what we have in the cloud. But we are conscious of power consumption on a holistic system level. On the other side, as Paul mentioned, you have to put some technology in the vehicle to enable it. But in automotive, we always are super conscious about power consumption, specifically when in vehicles and cars, we are more and more talking about electric propulsion, and that really makes a difference there.
David?
Okay, I think we're at time. There's still thoughtful questions popping up as we speak on the chat, so we will share this chat file with you.
Yeah. So David, you're trying to say something about computing power. Just finish it.
Oh yeah, I was just going to say. I mean, for us, we foresee in the next few years. I mean, I mentioned in one line during the presentation, right? This kind of shift, ML-ification of more and more parts of the system, right? Perception has been ML for many years now, but the drive policy moving towards ML. That will change the type of compute you need too, right? So it's not just about counting flops. It's about, all of a sudden we need, much bigger GPU memory and stuff like this to do more and more things using neural networks versus traditional approaches.
Right. Okay, very nice. I'm still reflecting on digesting the panel's thought. First of all, I really appreciate what, Paul, you mentioned about how to combine this machine learning approach with this failure mode effect analysis on that, right? They each have its established pathway. How do you embed that? We'd like to hear more detail on that. That's why. The second one, and David and both mentioned the sensor fusion. David, your point about moving from this late stage fusion to the early stage fusion. And it really use machine learning as a way to draw an understanding, particularly how you dynamically weigh different parts of sensor depending on the scenario. That would really important point. The third one, I really appreciate this business ecosystem discussion, the dancing between OEM, tier one, the chip maker, from tier 2 try to be tier 0, and that's a very interesting dynamic to look at. The last one to John's point about the technology progress seems to has not been translate into affordability? And if anything, is maybe the different direction. So how would that play out? That's another important topic. So thank you so much to the panel, and everybody please join me. Thank Paul, David, and Harold for the presentation today. Great.
Thanks for having us, guys.
Our pleasure.
Thank you.
If you don't mind, stay a bit, and Paul will create a breakout room for a quick debriefing on that. And for the audience, thank you for joining us. Next week, we have the head of research from Waymo joining us, talk about the latest technology progress in the Waymo autonomous driving. Have a good weekend and see you next Friday. Bye-bye.